underneath the review, typically I'm going to call it the resources, practice, and field report exam. You look under there, this is what you're going to get as a review for the final. You will get this sheet. So you'll have conversions azimuth to bearings, you'll have your declination, you'll have your area formulas, and you'll have your latitude departures, your miscellaneous, linear misclosure, relative precision. You will have every equation you need for the final. Okay? Now, let's go ahead and take a look at the final. This is posted in Blackboard also, so here's your review. The first question you're going to have to do is, all the questions are basically going to be part from the beginning question. Now, you're going to look at the parts and they're going to be part of a traverse. So basically we have a traverse that goes from point A to B to C. We know that from A to B, if this is north, that it has an azimuth of 207 degrees, 6 minutes and 59 seconds. All right? That means that the azimuth of this line is 207 degrees, 6 minutes and 59 seconds. All right? That's going to be your start point. The other thing that we have below in this information, and note, D and C prime is actually side shots. It is not part of the traverse. Only A, B, and C. So when you calculate the area, it's only A, B, and C. The other part that you have is you actually have X and Y coordinates. X and Y. Notice X is first, which is going to be your easting, and Y is second, which is your northing. Okay? And you have points for A, B, C, and D. But only A, B, and C are going to be used for your area calculations. So let's get started on the first question. All right. So the first question says, from the figure on the sheet, compute the angular misclosure and balance the angles to the nearest second and compute the bearings of all the lines in the traverse A, B, and C and from the adjusted angles. So the first thing we're going to have to do in this picture is add up all of our interior angles to see if they equal what? 180, because it's a triangle. If I had something different, it would be the sum of the angles for an interior polygon. Okay? Now, so write these down. You're going to take 80 degrees, 24 minutes, 55 seconds, 46 degrees, 46 minutes, 48 seconds, 52 degrees, 48 minutes, and 8 seconds. I'm going to add all of those together and tell me what you get. Okay? And they come up from here, here, and here. All right?
170.
What'd you get?
179 degrees, 59 minutes, 51 seconds.
Now tell me, is that 180 degrees?
No.
So what do I have to do? What is the misclosure? Exactly, we're going to take 180 degrees minus 179, 59, 51. What is that going to give us?
That should be 9 seconds.
9 seconds. All right, that is the misclosure. Okay, the angular misclosure. Now, how many angles do I have?
3.
I'm going to divide that by 3 and get what? 3 seconds. So I'm going to have to add 3 seconds to each of these to get my adjusted angle. So I get 80 degrees, 24 minutes, 58 seconds, 46 degrees, 46 minutes, 51 seconds, 52 degrees, 48 minutes, and 11 seconds. So if I add all of these up, I get 180 degrees, 0 minutes, 0 seconds. Okay? So these are my adjusted angles. Right? Now, the second part, it says calculate the bearings. For me to be able to calculate the bearings, I'm going to have to figure out my azimuths, then convert. All right. Remember what I said. Our initial azimuth on this is 207 degrees, 6 minutes, 59 seconds, right? So I'm going to start with my azimuth of 207, 6 minutes, 59 seconds. Okay? Now, remember the process. Azimuth, back azimuth, add an angle. Azimuth, back azimuth, add an angle. So I can get the azimuth of each line. So the first azimuth here is 207, 6 minutes, and 59 seconds. That's my azimuth of that first line. Okay? Now, if I drew the picture, the back azimuth from B to A is what? So this is A to B. So what do I have to do to get the azimuth from B to A? Do I add or subtract 180 degrees?
Subtract.
Anna's right. I'm going to subtract 180 degrees. So minus 180 degrees. So what's that going to give me?